Hello and welcome to the MathLeague Media YouTube channel. My name is Ian and today we're going to be going over target number 3 from our 12501 release, which was our first high school release for this contest season. Problem number 3 reads, a 2x2 grid of squares has each of its squares colored red, blue, yellow, or green, such that no two squares that share a side are the same color. Given that rotations and reflections of any coloring are considered distinct, compute the number of distinct possible colorings. Let's go ahead and draw this grid out. And think about the cases that satisfy our requirements in the problem. Now, if all 4 of the squares are colored the same color, aka we only use one color, then obviously 2 squares that share a side are also going to share the same color because we're only using one color. So there are no cases that use only one color. How about cases that use 2 colors? Well, if we were to use 2 colors, say red and blue, then the only ways to color these grid with both red and blue would be in this pattern, with 2 diagonals, the left diagonal and the right diagonal being either red or blue, and opposite one another. There's 2 ways to do this because reflections count, and there are 4 ways to pick the color for this left diagonal that starts in the upper left corner and ends in the lower right corner. That's 4 ways. And then there are 3 choices for the color that's part of the right diagonal, which starts in the upper right corner and ends in the lower left corner, for a total of 12 different ways to color the grid in this case. I'm going ahead and drawing us another grid and thinking about the case where we use 3 different colors. If we use 3 different colors, then one of these colors will have to be doubled up. And just like in our case, using 2 colors, those 2 squares will have to be diagonally opposite one another. Then our other 2 colors can be placed in the other 2 spaces in the remaining diagonal, and it doesn't matter which is which in that order. So there are 2 choices for the diagonal in our grid, which has 2 squares of the same color. And then 4 choices for that first color, times 3 choices for the second, times 2 for the third, for a total of 2 times 4 times 3 times 2, or 48 acceptable cases when we use 3 colors. And finally, in the cases where we use 4 colors, then every single square is going to be a different color, so we don't have to worry about the arrangement of them at all, as no 2 squares will have the same color whether they share a side or not, and that can be arranged in 4 factorial ways, or 24 ways. So the total number of distinct possible colorings for this grid is 12, plus 48, plus 24, or 84, which is our answer. Thank you very much for watching, and we'll see you in the next one.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.